Hey everybody, welcome back to Tech Junior Tutorials. My name is Lee Warwick Jr. and we're doing Advent of Code, and today is day 10. So let's check out this puzzle. So day 10 is monitoring station. They talk about flying into an asteroid belt, and you're supposed to find the best spot for a asteroid monitoring station. So without reading all this, they give you a little example down here with these pound signs or hashtags and the dots. And so basically you can land on one of these asteroids, and your job is to find which asteroid can see the most of the other asteroids. So they give you these numbers down here. So what this is telling you is that from the 6, you have a line of sight to 6 other asteroids. Same thing for the 7, for the 5. And then the best spot that can see the most asteroids is 8. And so they give you like a little example of how this line of sight works, because it's not really too obvious if you're looking at it like this. Basically, if you're looking through these asteroids, so maybe you would think of this like slopes and like Algebra 1 stuff from middle school or high school, where you've got like a right-up formula where you go like an x change, so like x1, 2, 3, 4, and then you go down 1, 2, 3, or something like that. So they give you like a dy and a dx if you're coming from like calculus or something. So basically the challenge is you can only see asteroids that are not behind or that are like directly in that line of sight. So anything that's behind an asteroid, so if an asteroid is behind another asteroid, you can't see that one. So for instance, this asteroid in the middle, you cannot see that one or that one. You can only see the one directly next to it, or this way. See that one, you can see that one, see this one, and this one. So that makes sense. But when you look at, let's say an example like this one, you might be thinking like, okay, if I draw a line of sight, you know, like down here, you might say like, man, I don't really know if I could see that one, or even like that one, or this one, or something like that. But you have to think of this as like the hashtags are a little bit smaller than this. Maybe if you were looking at the dots and using like a ruler or something to line them up. So it's not really obvious how that would work, but basically at my first pass on this, I thought like, okay, that's the direction I can go, and then like directly diagonal like these C's are doing, be a direction, and then like down. But if you look at it, you can do like over 1, down 3, and then the next E would be over 1, down 3. And because that one's on the same line, it's the same slope or change in X and change in Y, that means that that E is behind this E. And so you can't see those two E's. You can't see the F's or the D's or the C's, G's, B's, or A's in there. Only the capital letters are what you can see here. So even this G kind of illustrates what I'm talking about. These A, B, and C look like they're blocking G, but they're really not, according to the puzzle's logic. So I got kind of hung up on that for a while. Then they give you a bunch of test cases, which is really nice of them. The most helpful one, I think, is this one in the middle. Some of these other ones, especially like the first one, I ended up using this one a lot because it wasn't a whole lot of information to parse. But what's bad about this is that because that spot they give you that's the best spot is on the bottom, it doesn't really help you debug the any possible locations below or to the right. So that was a bit of a challenge. But yeah, this one where it says 1113, which is there, I don't know if you can see it, with 210 asteroids, that's the one that I ended up using the most. for my debugging. So I got that answer, and we'll check that out real quick. So I kind of embarrassed that I wrote a ton of code for this, but I first used the same stuff I've been using to grab text input from a file. Ended up calling split lines, just storing the whole thing and then doing an enumerate instead of doing like a file.read and then for line in file.read or something like that. I'm still playing with this, still getting used to Python, so still working on that. I finally got this string join method to work for me. So I use this small function to just print the asteroid map, just like you see on the puzzle input, like this, without commas between everything. So I'm storing everything again as a two-dimensional list in Python. So the rows, like that would be a row. That's going to be the outer list. So each row is in a list, and then each position in that row is in that list. So that's the y value would be going this way, x value would be going this way. But in Python, or at least the way that I stored that, the way that you would access it all the way down here would be like y on the outside and then x. So you can see I wrote a whole lot of code for this, which is kind of embarrassing. But so I stored my locations like that, parsed the map, and then I have a little method or function to print the map. Ended up deciding, kind of learning my lesson from previous days, that I needed to use a set or a map or something, or a hash map or whatever, so that I don't have like duplicates, just to kind of double check that and be able to do a really fast lookup without having to parse a list over and over and over again, searching for a value. So that was really helpful. Went ahead and stored my values as like a pipe separated string. So kind of what I did here was I worked out that for this workflow, I wanted to know, like, okay, if I'm going to find all the different like lines that I can do. So for instance, going back to the simple example, so like this A is a line, B, G, C, D, E, even F. Like I need to know how wide this thing is and like how far am I from an edge. So like I need this distance, need that distance, and so on. So I went ahead and wrote a function for that just gives me a dictionary back with like my distance to each side. And then I have this formula to find the slopes. So that's what I like to think of when I'm thinking about lines. That's, I guess, one of the few things that stuck with me from grade school math. But so these first four values that I grab, I just say like, hey, if I have any amount of distance from any of those sides, like this is the line that I'm going to do, which is just a set of horizontal and vertical lines. And then I go ahead and check for, again, trying to not duplicate slopes, because that actually did bite me still. I went ahead and grabbed the 1, 1 direction, so like a perfect 45-degree angle diagonal line. So that would be like if you had a cross, that would be another cross going through. I don't know if that makes a whole lot of sense, but so I got those perfect 45-degree angle lines also that I check for right away. And then I check for kind of everything in between there. So I do that with a bunch of nested for loops, just counting up from 1 to the distance plus 1 of the distance to each side, so in each direction. So like I look at increases in both positive x and positive y, negative x, negative y, and then positive, negative for each one. Beyond that, that worked to give me all of the different slopes, but it gave me a interesting problem, which was, for instance, so like looking at this example with the 8, you can go -1, -2. I'm sorry, -1 up to, right? But you can also get -2, negative or positive 4. And that's the same line. So you shouldn't be able to see this highlighted 7 here from the 8 because they're on the same line. But what I ended up getting was that because I was counting upwards to the edge, finding all these different slopes, I ended up, like, because I'm going all the way to the edge, I would get, like, in this case, -1x, positive, or no, I guess you'd call this like negative, negative, -1, -2 for a slope. So up 2 and left 1. And that's the same thing as left 2, up 4. So it's like a multiple. So I needed to basically find a way to reduce fractions with code, which is a really hard thing to do. It's easy when you look at it. You're like, oh, 2/4 is the same thing as 1/2. But in code, that becomes like a whole different problem. So I'm sure that this isn't the most efficient way of doing it. But what I do here is I grab, first of all, I create a set, and then I go through all of the slopes that I've grabbed so far, and I look for, first of all, if either one of them is 0, that means that I've manually added them. If the x or y value is 0, I just go ahead and pop that in the set. But otherwise, I check out the maximum value of either one of the x or y, and then basically count upwards from there. And if I find a number in between 0, or I'm sorry, in between 1 and the maximum value that divides evenly into both numbers, then I know that I can reduce both numbers by that. So I use modulo for that, and then I do this // in Python, which is like a quick way of rounding down when you divide, and also gives you an integer instead of a float back. So that's a different thing to deal with from JavaScript, where you do have different types underneath the hood, but like JavaScript doesn't really care about, whether something is an int or a float or whatever. Just gives you the, if it's an even number, it's an even number. So with Python, that wasn't the case. I saw right away whenever I was dividing this, even though these should be non-fraction numbers because I'm using, again, modulo equals 0. It still popped out like 4.0 or 2.0 or something like that. So after that, I get the reduced value, and then I check like, hey, if my original value was less than 0, that means it was a negative number. So I convert that and then add that to the set, and then pop that back out from this function as a new set of deduplicated slope values. Then from there, I have a find asteroids function, which basically leverages all the other stuff that I've written. So I grab like my origin points, I grab all the slopes from that point, I grab the width and the height, and then for each slope value, I check, basically I start at the origin, and then I move by whatever the change in x or the change in y is, until I'm out of bounds. So if I'm beyond the width or the height, then I stop looping. So then from there, if I am, this is again just a check to see if I'm within the boundaries of the grid. If I'm in there and I'm on the next position, and that position is a hashtag, then go ahead and say like, yep, that's an asteroid that I found. Convert it into a string, and then add that to the set, and then break. And then otherwise, if I do that change in x and y, and I'm not within the bounds, then I know that I'm out of bounds, and I should stop looping. And then from there, I just return the length of the set. I wanted to have all the values of the asteroids that I was able to find, instead of using just a counter for debugging purposes, so I could like look at the simple examples, like this one, and see like, okay, do I have that asteroid, that asteroid, that asteroid, that asteroid, and all the rest, but not that one. So if I had 8 values, or did I had 7, and which one was I getting that I wasn't supposed to be getting, and stuff like that. So that was really helpful. But for the actual code itself, like I just wrapped the length function around that. And then from there, it's just a matter of looping over all of the points in the grid. Eventually, this took like 3 or 4 seconds because I wasn't checking if the point that I was on was an actual asteroid, so that tripped me up. So I was looping over, like in this example down here, every period I was doing another check, and then that would give me the wrong answer because I was trying to like find a spot there that could, you know, hit all of these asteroids, but that wasn't actually a possibility because it has to be on one of these hashtags. So from there, I just did a basic check that says like, hey, if I first of all spit out that number of asteroids and then say, hey, if that's bigger than the previous value, great, that's the spot, and then spit out or save the x and y coordinates. And at the end, I just print that. So if you run that, takes a second, and then it pops out 314, which was the answer that I was looking for today down here. So part 1 was pretty challenging, but it set you up nicely for part 2. However, there was quite a bit of extra stuff to think about with part 2. So basically it says the elves decide that there's too many asteroids and they need to vaporize them with a laser, which is fun, but the laser only runs clockwise and it can only destroy one asteroid at a time. And so this is kind of an example of the order in which these things would get shot. So that's first, second, third, fourth, fifth, sixth, 7th, 8th, and 9th. So obviously moving clockwise, but how do you calculate that if you're talking about an XY coordinate system? So I tried to do this without getting into trigonometry, but I failed. could not get it. I thought there was like a simple check between these two values, the change in y versus like the change in x, that could tell me the order of the slopes going from noon. So they say straight up somewhere. Yeah, laser starts by pointing straight up and rotates clockwise. So this obviously is a change of 0, y of 1. And that's just that straight line. So starting with that and then going to even here, like trying to find the slopes in order with basically a decreasing angle. If you're looking at like this line versus like this line, trying to do that with some quick math didn't really pan out for me. I tried a lot of different ways to get it, but couldn't. So I knew like first I wanted to find that value and then these values, and then kind of divide this up into 4 coordinates. And then from there, I've got slopes that I know I could fit in between that chunk. So like all the numbers here basically. But the problem is how to order those. So if you're going to do this, you have to be able to order the slopes in here from, like, if this is 0 degrees to 90 degrees, you know, counting upwards from there. And so you've got an X and a Y value. And with like Python and programming in general, there's usually like a custom sort function that you can do. So way down here. Now what I've done is I've written another order slopes function, and then that has like another helper function within it. So this helper function is what I'm using to sort a slope value. And originally I thought like I can check to see if the X is bigger, the Y is bigger, or add them together or something like that. And that would give me like return one or the other, the X or the Y. And like in increasing order, like behind the scenes, it would just work out because I was working in those different coordinates. So like, again, this coordinate here, like this chunk, I know that my y value is going to decrease and my x value is going to increase. So like the negative and positive isn't going to flip in that section. So I figured there could be some simple math to do it. I think there is. I think I've heard people saying like divide y by x, and that gave it to them. But for me, I didn't get it. I ended up looking on, in the back of my mind, I was thinking like trigonometry. And then I saw on Twitter, somebody posted a GIF of, talking about advent of code. And they're like, oh yeah, I used trigonometry for it. And I was like, you know what? I'm just going to use trigonometry. So that's what I ended up doing. And I used this arctangent 2 function in Python. I think this is built into a lot of different languages, probably in JavaScript and some other things attached to the math library. But basically, if you look down here, I didn't really brush up too much on trigonometry for this, but it says that if you give it a y and an x, it should give you the radians, which is like a multiple or a division of the value of pi. So if you look at so 1 radian is like pi over 2 or something like that. 2 radians, 2 radians is equal to 360 degrees. So basically, it should give you an increasing value like as you traverse this circle here. This might be a good one. Right. There you go. So that's like, man, Wikipedia on point with the GIFs. This is pretty impressive right here. Yeah, basically you're tracing this this circle around the outside. So like, so your radians increase as the angle increases. So there's 180 degrees is equal to pi radians. And then all the way around is 2 pi r, or 2 pi radians. So that's basically what I was working with. I knew that either, like, if I could get that arctangent with the, what is it, like the adjacent over the opposite side or something like that, if you remember SOHCAHTOA from trigonometry, I figured if I did that, either I could, it would either give me the right answer right off the bat, or I would just have to reverse the sort order and have it go in the other direction, and that would give it to me. So that's what I ended up using. Worked out fine. But the code that I had to use to get there was pretty ugly. So like I said, I chunked everything into x increasing, like y decreasing. I added in the horizontal and vertical lines manually, and then got the values between those horizontal and vertical lines. That gave me the 4 quadrants, and then I filtered for those basically, and then sorted based on that sort function. So I saw actually in Ali Spittles, one of her Python solutions for this for a previous day was using Lambda like this, and I thought this was pretty cool. So with JavaScript, like we would do like an arrow function and just call the other function within. Here you can just do Lambda and say like, here's the value that's going to get passed in, and then just right here call that other helper function. So that's what I ended up using, which was pretty nice. So I was glad I got to use that. And then this is what they call it, like a name default or something like that in Python. So you can say like, instead of using like passing an object or something in JavaScript and doing key value pairs, you can still give it a value, and then these optional values can be, they're kind of like named. So you can say like, okay, I can pass my values in out of order, and then it doesn't matter as long as I specify which thing I'm passing in. So that's pretty nice as well. But yeah, once I do that, I add all those things together, and then here I'm passing slopes into reduced fractions, which gives me back the deduplicated slopes, and then that goes into order slopes. So that arranges them, and then that spits out everything in order, which is good. So aside from that, the only thing I changed was instead of returning the length, I just went ahead and returned a list of found asteroids, and made sure to convert it to a list from a set like I had in the previous example, because a set will not preserve the order, even though it deduplicates things. So use the list, and then for that, I wrote another function to vaporize asteroids. So this just calls stuff out of the global scope. It says, hey, while there's still asteroids, go ahead and do a loop. Find asteroids from a given point, pass in that map, and then if the length of the list is greater than 0, go ahead and loop over it, and every time that you hit a hashtag in that list, which is kind of like an unnecessary check because I already have the coordinates, I've already checked it, but just to be safe, like, hey, if there's a hashtag there, go ahead and call it a dot, and then count upwards. And then I said, hey, if I hit 200, go ahead and print the answer. So they give you that little formula, multiply the x by 100 and add it to y, and that gives you like the like hundreds or thousands and hundreds place and the tens and ones place for your answer. But what I did, which was really cool, was I saw on Twitter somebody had printed out a a visualization of the actual asteroids being shot by the laser. So I tried to do that with like a clear return character or whatever. But I found on Stack Overflow somebody said like, hey, this will work cross operating system. So if you call os.system either CLS or clear, that will kind of clear out the console between each print. So I use my print asteroids function after I zap an asteroid, and it actually visualizes the asteroids being vaporized, which I thought was like super duper cool. So I do that, and then at the very end, I print what the 200th asteroid was and the total amount vaporized. So we can go ahead and do that real quick. I'm going to zoom out, and you can watch the fireworks. There we go. You can see it moving clockwise and blasting everything. And we make another pass. Now it's going faster. And bam. So that is all of the asteroids vaporized. So the 200th was at X15, Y13. And the total amount, if you're curious, 388 in the input for me for today. And if we go back to our puzzle, all the way down here at the bottom, 1513 was the answer that I was looking for. So that was pretty cool. Again, they give you a bunch of different test cases, which is nice. This part was especially helpful because you know if you're hitting like all of these, and especially like if your 200th one is 8,2 or 0802 according to this formula, you know that you're in good shape. So I use that. I use the very last one here to test my laser sniping against, and came out with the right answer. So I was pretty happy with that. Okay, that's all I've got for day 10. This was pretty fun, even though it was pretty dang difficult to get all the math right for this one. Did not expect to be using like trigonometry and algebra and all that stuff again so soon after the intersecting line segments madness of I think day 3. So hopefully tomorrow's a little bit easier. And yeah, I'm having a good time with these now. I kind of feel like I'm hitting my stride. But yeah, I could see these being pretty brutal for a lot of people. So definitely if you're getting stuck at home, believe me, I'm getting stuck too. That's why I'm not live coding these or doing like a stream or anything. These are super difficult. I pound my head against the desk pretty often solving these. So it's good practice, but I would hate to get a problem like this on a whiteboard or something. All right, that's all I've got for today. I will see you tomorrow.